Hello my dear students, my name is KESHAVA MURTHY and working as a lecturer in chemistry. Today I am going to discuss some of the neat questions based on the concept that is P block element. In that 16, 17 and 18 group elements. Let us move on to the questions. Question number 1. At ordinary temperature and pressure, chlorine is a gas, bromine is a liquid and iodine is a solid. This is because, please remember, the physical state of the any elements is mainly decided on the basis of intermolecular force of attraction. If you observe the chlorine, bromine and iodine, it belongs to the group halogen, that is 17th group element. The intermolecular force present in between these is the van der Waals force of attraction. As you move down the group, the van der Waals force increases. Now, if you observe in case of chlorine, the van der Waals force is weakest, and in case of iodine, the van der Waals force is strongest. That's why the chlorine exists in gaseous state and iodine exists in a solid state. Now, if you consider this concept, the option 4 is the right answer. That is, intermolecular forces are weakest in chlorine and strongest in iodine. Next, we'll move on to question number 2. The correct order of the thermal stability of hydrogen halide is. The thermal stability is mainly based on the strength of HX bond. We know that as you move down the group, as the size of halogen increases, the bond length between hydrogen and halogen atom goes on increases. As the bond length increases, the thermal stability goes on decreases. Therefore, the option 2nd is the right answer. Let's move on to the question number 3. The correct order of increasing bond length of F2, N2, Cl2 and O2 is. Now, if you consider these molecules, as the number of bond increases between the two atoms, nitrogen is a diatomic molecule, oxygen is a diatomic molecule, fluorine is a diatomic molecule, chlorine is a diatomic molecule. Now, number of bond between the two atoms increases, that is called as multiple bonds. The bond length goes on decreases. We know that between nitrogen and nitrogen atom, triple bond is present. Between oxygen and oxygen atom, double bond is present. Between fluorine and fluorine, single bond is present. That's why the nitrogen has less bond length when compared to oxygen, when compared to fluorine. Now, if you consider fluorine and chlorine belongs to same group. That's why fluorine is smaller, chlorine is a little bit larger. Therefore, bond length in chlorine is more when compared to bond length in the case of fluorine. That's why the option 2nd one is the right answer. Next, we'll move on to question number 4. Which one of the following orders is not in accordance with the property stated against it? Now, see the option. Fluorine, chlorine, bromine, iodine, electronegativity. We know that as you move down the group, electronegativity decreases. The fluorine is the highest electronegative element. So, therefore, the first given property is correct. If you observe the second one, chlorine, bromine, iodine and fluorine, bond dissociation energy. This option is not correct. Why? Because in case of fluorine, the bond dissociation energy less than the chlorine and less than the bromine. That is because even though it is smaller in size, the fluorine bond dissociation energy is less than the chlorine and bromine. That is because of the interelectronic repulsion between fluorine and fluorine atom. Now, what happens? Due to that interelectronic repulsion, the bond dissociation energy of fluorine is less than the chlorine and bromine, but it is more than the iodine. Therefore, the correct order should be chlorine, bromine, fluorine and iodine. Therefore, order is not in accordance with the property stated against it. Therefore, second one is the right answer. If you observe the third option also, fluorine, chlorine, bromine and iodine, oxidizing power, that is also correct, because as you move down the group, oxidizing power goes on, decreases. Then HI, HBr, HCl, HF, acidic property in water. HI is the strongest acid, HF is weakest acid. So among the hydrogen halide. Therefore, option second one is the right answer. Let's move on to the question number 5. Which of the following oxo acids of chlorine is the best oxidizing agent? Now, if you observe HOCl, HClO2, HClO3 and HClO4, as the oxidation number of chlorine increases, the covalent nature of the bond between chlorine and oxygen increases. As the covalent nature increases, the bond becomes stronger. Therefore, its oxidizing property goes on, decreases. If you observe, in case of HOCl, the oxidation number of chlorine is +1. In case of HClO2, oxidation number is +3. In case of HClO3, oxidation number is +5. And in case of HClO4, oxidation number is +7. Among these, HOCl is the lowest oxidation number for chlorine. That's why it is the strongest oxidizing agent. Therefore, option first is the right answer. Next, move on to the question number 6. The acid employed for etching of glass is. What happens? The hydrogen fluoride react with the sodium silicate and forms a soluble complex, that is sodium fluorosilicate is formed, which is soluble, and that's why we can write on the surface of glass by using hydrofluoric acid or HF. Okay, so therefore option third is the right answer. Okay, next move on to the question number 7. The electronic configuration of 4 elements A, B, C and D are: A is equal to 1s2, B is equal to 1s2, 2s2, 2p2, C is equal to 1s2, 2s2, 2p5, D is equal to 1s2, 2s2, 2p3. The tendency to form electrovalent bond is largest in. Please remember, electrovalent bond means ionic bond. The ionic bond is formed between the two oppositely charged ions. The positive ions are formed when it loses electron readily. The negative ions are formed when it accepts electron very easily. Now, if you observe this electronic configuration, the C in that electronic configuration is very nearest to a noble gas configuration. If it accepts one electron, it reaches the octet electronic configuration and it forms an ion. Therefore, option 2 is the right answer. Next, move on to the question number 8. What products are expected from the disproportionation reaction of hypochlorous acid? What do you mean by disproportionation reaction? The disproportionation reaction is the one in which same substance undergoes oxidation as well as reduction. When it is possible only when the element present in that compound should be exist in the middle oxidation state. Now, hypochlorous acid, that is nothing but the HOCl, where the oxidation state of chlorine is +1. Now, it undergoes a disproportionation and it forms HCl, where the oxidation state is -1, and HClO3, where the oxidation state is +5. Now, +1 to +5, it is oxidation. +1 to -1, it is reduction. Same substance undergoes oxidation as well as reduction and forms HCl and HClO3. Therefore, option 4 is the right answer. Next, move on to the question number 9. The correct order of acidic strength. Now, acidic character of non-metallic oxide increases as the non-metallic nature of the element increases. Therefore, if you consider this, the Cl2O7 is strongest acid than the SO2 than the P4O10. Therefore, option first is the right answer. Next, move on to the question number 10. The correct order of increasing the conjugate base strength is. Now, here hydrogen halide is given. HX dissociate to give H plus plus X minus. Now, if acid is stronger, its conjugate base is weaker. So, this is acid and this one is conjugate base. Now, if you consider hydrogen halide, Hi is the strongest acid and HF is the weakest acid. Now, if you consider that, the first option is the right answer. Next, move on to the question number 11. The ease of liquefaction of noble gases decreases in the order. Now, if you consider the noble gas, as you move down the group, the van der Waals force goes on increases between the atoms. As the van der Waals force increases, the liquefaction becomes easy. Therefore, as the atomic mass of noble gas increases, van der Waals force increases down the group. Hence, the order of liquefaction becomes the second one. That is, xenon, the liquefaction is very easy because the intermolecular force is stronger. Helium, it is very difficult to liquefy because the van der Waals force is very weak. Therefore, option second is the right answer. Next, move on to the question number 12. The correct order of increasing hydration energy of the following conjugate bases of oxo acids of chlorine is. Now, please remember, the oxidation state of the central atom increases. Its hydration enthalpy also increases. Therefore, if you observe in this ClO minus, where the oxidation state is +1, ClO2 minus, where the oxidation state is +3, ClO3 minus, where the oxidation state is +5, and ClO4 minus, where the oxidation state is +7. Now, in the case of ClO4 minus, the hydration enthalpy is very high because oxidation state is +7. That's why it easily get hydrated. Therefore, option first is the right answer. Next, move on to the question number 13. The geometry of XeF6 molecule and hybridization are. Now, how to find out this hybridization? The hybridization can be easily find out. Here, the number of electron present in central atom, that is Xe, is 8. Half into 8 plus number of electron donated by the fluorine is 6. That is equal to 7. The hybridization should be sp3d3 hybridization. sp3d3 hybridization. If it is sp3d3 hybridization, it is having the geometry pentagonal bipyramidal, or we can call it as distorted octahedral geometry. Therefore, if you observe this, the second one is the right answer. See here, the molecule is XeF6 having this structure where it is called distorted octahedral geometry. Next, move on to the question number 14. Among the following oxo acids, the correct decreasing order of acid strength is. Now, acid strength of oxo acids of the same halogen increases with increase in oxidation number of halogen. As the oxidation number increases, the acidic strength also increases. Now, if you consider that here HClO4, the plus 7 oxidation state, HClO3 plus 5, HClO2 plus 3, and HOCl where it is plus 1 oxidation state. Therefore, option third is the right answer. Next, we'll move on to the question number 15. XeF4 on partial hydrolysis produces. Now, partial hydrolysis of XeF4 takes place as follows. That is, XeF4 undergoes hydrolysis, gives XeOF2 plus hydrogen fluoride. Therefore, the XeOF2 is formed, hence option second is the right answer. Next, we'll move on to question number 16. The reason that only xenon fluorides are known but the corresponding chlorides have not been reported. Please remember, the molecule exists only when the bond between the two elements is stronger. Now, if you observe the first option, high bond energy of xenon fluorine and low bond dissociation energy of fluorine, that easily forms xenon fluorides. But xenon chloride is not formed. Why? Because if you observe the second option, that is a smaller bond energy of XeCl, and because of smaller bond energy, the formed molecule becomes less stable, and also larger bond dissociation energy of Cl2. The energy required to break the Cl2 molecule is very high. That's why xenon chloride will not be formed very easily, and hence both 1 and 2 are right answer. That's why option third is the right answer. Next, we'll move on to question number 17. Argon is used in arc welding because of its. We know that noble gases are used to provide inert atmosphere during metallurgical operation. Please remember, at high temperature, metal react with oxygen and forms a metal oxide. In order to avoid this reaction, what you will use? You will use the noble gas. That is, argon is used. Therefore, the option first is the right answer. Low reactivity with metal, and because of that, oxidation of metal do not takes place. Next, we'll move on to question number 18. Which of the following is a explosive compound? It is a fact question. That is, XeO3 is a explosive compound. Next, move on to the question number 19. A degenerate gas is. We know that the lowest boiling liquid known to mankind is helium. That is, it boils at 4.2 Kelvin. Now, we know the property of liquid. Suppose if you poured in a container, it remains in a container. But if you cool liquid helium to 2.2 Kelvin, you will get helium-2 is formed. It has a special property that it climbs the walls of the container and flows like a liquid. It climbs the wall of the container, and that's why it behaves like a gas. That is because the helium-2, it climbs the uphill, and that type of property is seen in the case of gas, and hence option third is the right answer. Let's move on to the question number 20. Which of the following is used as an anesthetic due to the formation of aqueous clatherides in physiologically strategic spots? The clatherides are cage compounds in which the noble gases are trapped in the cavity of organic or some of the inorganic compounds. Now, xenon forms a clatherides in aqueous media so that it acts as a anesthesia. As long as anesthesia is supplied, the person loses consciousness. Once again, the anesthesia is stopped. What happens? The clatheride equilibrium is destroyed and clatherides undergo decomposition, and because of the decomposition, once again that person regains a consciousness. Therefore, the xenon forms a clathrite compound so that it acts as an anesthetic agent in the physiologically strategic spot. Therefore, option second is the right answer. Next, move on to the question number 21. Which one of the following reactions of xenon compound is not feasible? Now, if you observe all these reactions, the first reaction XeO3 6HF gives XeF6 and 3H2O. But please remember, this reaction is not feasible. Why this reaction is not feasible? Because reverse reaction, it undergoes hydrolysis immediately and gives XeO3 and HF. And because of this reverse reaction, this reaction is not feasible. Therefore, option first is the right answer. Next, we'll move on to the question number 22. The T-shaped interhalogen compound is. Now, if you observe the option ClF3, ICl, ClF5, IF5, all these are interhalogen compounds. In that ClF3 is bent T shape. It is like this, bent T shape, where it undergoes sp3 dehybridization, and among these 5 hybrid orbital, the 3 hybrid orbitals are occupied by the fluorine and 2 hybrid orbitals are occupied by lone pair of electrons, and ICl is a linear and ClF5 and IF5 are square pyramidal. Therefore, option first is the right answer. Next, move on to the question number 23. Which of the following chemical contains chlorine? Okay, if you observe the option Fischer salt, what is this Fischer salt? That is nothing but the potassium hexa nitrito cobalt third complex. In that the chlorine is not present. Next, Epsom salt, it is nothing but the magnesium sulfate heptahydrate, that is MgSO4 7H2O. In this also chlorine is absent. And Fremis salt, in this also potassium nitroso disulfonate complex, and in this also the chlorine is absent. But in the case of spirit of salt, what is it, the spirit of salt? The spirit of salt is other name for HCl, and that's why in HCl the chlorine is present. Therefore, option 4 is the right answer. Next, move on to the question number 24. Which of the following halogen has a metallic character? The metallic character is as you move down the group, in the case of halogens, the metallic character goes on increases. The metallic character increases because the ionization enthalpy goes on decreases down the group. Electronegativity goes on decreases down the group. Therefore, among fluorine, chlorine, bromine and iodine, iodine is having more metallic character and hence it is more basic. Therefore, option 4 is the right answer. Next, question number 25. Correct order of size of iodine species is. We know that when electrons are removed, it readily forms positive ion. When electrons are added, it readily forms negative ion. Please remember, always cation is having smaller size when compared to neutral atom. Anion is having larger size when compared to neutral atom. Therefore, option 4 is the right answer. Next, move on to question number 26. The lowest value of 0.53 volt for the electrode potential E0 for the reaction. Please remember, electrode potential is measured in terms of reduction potential. Now, X2 plus 2 electron gives X minus, and this is a reduction reaction because addition of electron is a reduction. Now, if you consider halogen, fluorine is the strongest oxidizing agent. Why it is the strongest oxidizing agent? Because its electrode potential value is plus 2.87 volt. If you consider chlorine, the electrode potential value is 1.36 volt. Bromine, it is 1.09 volt. Iodine is plus 0.54 volt. Therefore, the lowest value 0.53 is for iodine. Hence, option 4 is the right answer. Because of its lowest electrode potential value, it is the weakest oxidizing agent among the halogen. Next, move on to the question number 27. Fluorine reacts with dilute NaOH solution to give. Now, fluorine react with NaOH gives sodium fluoride and OF2. Okay. So, therefore, option second is the right answer. Next, move on to the question number 28. Noble gases are sparingly soluble in water due to. Now, noble gases are non-polar in nature, but water is polar in nature. Now, what happens when the noble gases are dissolved in water? This polar water molecule induces the polarity in non-polar molecules. Therefore, there is a dipole induced dipole interaction is seen, and because of that noble gases dissolves in water. Now, if you observe this dipole induced dipole interaction, therefore option second is the right answer. Next, we will move on to question number 29. The maximum number of compounds are formed by. The maximum number of compounds are formed by xenon. Why it forms a maximum number of compounds? Because in case of xenon, the atomic size is large. When the atomic size is large, ionization enthalpy becomes less. Ionization enthalpy becomes less, that's why it becomes more reactive. Hence, xenon forms number of compounds with highly electronegative atom, that is fluorine and oxygen. Therefore, option 4 is the right answer. Next, move on to the question number 30. Shape of XeOF4 is. First, we will see what is the hybridization. In XeOF4, the hybridization is sp3d2 hybridization, and it has one lone pair of electron, and if you observe the structure, it is square pyramidal. The structure is like this, square pyramidal. Okay, so therefore the option second is the right answer. Next, move on to the question number 31. Which of the following compounds cannot be stored in glass vessel? That is XeF6. Why? XeF6 react with SiO2 present in the glass and forms highly explosive compound, that is XeO3, and because of that it cannot be stored in glass vessel. Therefore, option 4 is the right answer. Next, move on to the question number 32. Which of the following light is effective in formation of chlorophyll? That is, neon light produces orange color glow which stimulate the growth of a plant. That's why the neon lamps are used in greenhouses. So therefore, option second is the right answer. Next, move on to the question number 33. XeF6 on hydrolysis gives. The XeF6 on complete hydrolysis gives, that is XeO3. Therefore, option first is the right answer. Next, move on to the question number 34. Hydrogen bonding is strongest in. The hydrogen bonding formed between the hydrogen atom with the highly electronegative atom, that is fluorine, nitrogen and oxygen. If the electronegativity difference is more, the bond formed between hydrogen and other element becomes stronger. Now, if you consider the electronegativity difference in case of hydrogen and fluorine is more, that's why the hydrogen bonding is stronger in case of hydrogen and fluorine. Therefore, option third is the right answer. Next, we will move on to question number 35. Which of the following is the life-saving mixture for an asthma patient? Please remember, for asthma patient, the mixture of helium and oxygen is given, and this mixture is used to treat the asthma patient. Therefore, option first is the right answer. Next, question number 36. Caliche is. The caliche is nothing but the chili salt petre. Sodium nitrate is called as a chili salt petre. Potassium nitrate is called as Indian salt petre, which contains iodine as sodium iodate, which is present in a caliche. Therefore, option second is the right answer. Next, we'll move on to question number 37. Which member of the halogen family does not show positive oxidation state? Please remember, the fluorine is the highest electronegative element. It will not show positive oxidation state, and also it shows only one oxidation state, that is -1, that is due to non-availability of d orbital. Therefore, fluorine is the right answer. Therefore, option first. Next, we will move on to question number 38. The correct order of electron gain enthalpy, negative value of halogen is. Now, electron gain enthalpy, as the size of halogen increases, electron gain enthalpy goes on decreases. If you consider this, the order should be fluorine, chlorine, bromine and iodine. But chlorine has more negative electron gain enthalpy than the fluorine. That is because of inter-electronic repulsion. In case of fluorine, inter-electronic repulsion is more. Hence, in order to overcome this inter-electronic repulsion, some energy is absorbed. Therefore, liberated energy is less. But in case of chlorine, it is a little bit larger. Inter-electronic repulsion is less. That's why liberated energy will be more. Therefore, the chlorine has a more negative electron gain enthalpy when compared to fluorine, bromine and iodine. Therefore, option third is the right answer. Next, move on to question number 39. The spectrum of helium is expected to be similar to that of. Now, if you observe the spectrum of helium, the helium is a di-electron system. 2 electrons are present. In the case of lithium plus, also it contains 2 electrons, and because of that both are having similar type of spectrum. Therefore, option second one is the right answer. Next, we will move on to question number 40. XeF4 and XeF6 are expected to be. Please remember, that is the xenon tetrafluoride, xenon hexafluoride. These are strongest oxidizing agent. It can be used for fluorinating agents. Therefore, option first is the right answer. We will move on to question number 41. The colored discharge tubes for an advertisement mainly contains. In the advertisement, the colored discharge tube contains neon. Why the neon is used? The neon light can easily pass through fog and mist. Therefore, the advertisement is clearly visible from the faraway distance. Therefore, option third is the right answer. Next question. Question number 42. Clatharides are. What are these clatharides? The clatharides are nothing but the cage compounds, where the noble gases are trapped in the cavity of organic or inorganic compounds, and these compounds are called as clatharides, and these clatharides are non-stoichiometric compounds. Clatharides are non-stoichiometric compound. Therefore, option first is the right answer. Next, we will move on to question number 43. Halogens are colored because. The halogens are colored because it absorbs the light radiation from the visible region. When it absorbs the light radiation from the visible region, by using that energy, it goes to excited state. The electron in the excited state is highly unstable, jumps back to lower energy and giving extra energy in the form of radiation that falls in the region of visible spectrum. Hence, halogens are colored in nature. Now, if you observe that fluorine is a pale yellow in color, chlorine greenish yellow color, bromine reddish brown color, and iodine is a deep violet color. This is because their molecule absorbs visible light, causing the excitation of outer electrons to higher energy level. Therefore, option third is the right answer. Next, we will move on to question number 44. Bleaching mixture is formed by passing chlorine through dilute NaOH solution below 25 degrees centigrade, and it forms NaCl and sodium hypochlorite is formed, and this mixture is called as bleaching mixture. That is, sodium chloride and sodium hypochlorite is called bleaching mixture. Therefore, option second is the right answer. Next, we'll move on to question number 45. Iodine flask, when rubbed with liquor ammonia, gives dark brown precipitate of. When ammonia reacts with iodine, it forms a ammoniate complex. Ni3 ammonia complex is formed, and because of the formation of this complex, it forms a dark brown precipitate. Therefore, option third is the right answer. Next, we will move on to question number 46. In BRF3 molecule, the lone pairs occupy equatorial positions to minimize. The lone pair occupies equatorial positions to minimize the inter-electronic repulsion. There is a repulsion between the lone pair, and in order to minimize the lone pair repulsion, it occupies the equatorial position. See the structure of BRF3. It has a bent T-shaped structure where these two lone pair is occupied the equatorial position. Hence, the option 4 is the right answer. That is, lone pair repulsion only. Next, we'll move on to question number 47. The electronic configuration 1s2, 2s2, 2p5, 3s1 represents which of the following? Now we have to see the option for this type of questions. Now see, an excited state of fluorine. If you see the excited state of fluorine, that is 1s2, 2s2, 2p5 configuration. So 2p5, that 3s1, one electron is extra, that is not possible. Next, ground state of neon. The ground state of neon is nothing but the 1s2, 2s2, 2p6. But the 3s1 is present, it is not ground state. Okay. So next, we'll move on to an excited state of oxide ion. Oxygen is having 8 electron, oxide ion 10 electron. Now, electronic configuration of oxygen in the ground state is 1s2, 2s2, 2p4. Electronic configuration of oxide ion is 1s2, 2s2, 2p6. Now, electronic configuration of oxide ion in the excited state, one electron shifted to outer orbital, that is 1s2, 2s2, 2p5 and 3s1. Therefore, the electronic configuration 1s2, 2s2, 2p5, 3s1 represents the excited state of an oxide ion. Hence, option third is the right answer. Next, we'll move on to question number 48. The decreasing tendency to exist in Foucault 8-membered ring structure is. We know that oxygen is a diatomic molecule. Why it is a diatomic? Because it can form p-pi multiple bond. But other elements cannot form p-pi multiple bond. But other element exist in 8-membered ring structure. Now, as the size of the atom increases, the tendency to exist in 8-membered Foucault structure goes on decreases. Now, sulfur is having more tendency to form 8-membered ring. As you move down the group, its tendency goes on decreases. Therefore, option first is the right answer. Next we'll move on to question number 49. Which one of the following has the highest tendency towards catenation? Catenation is nothing but the self-combining capacity. If you observe the 16th group element, the catenation property decreases down the group. If you observe oxygen, oxygen forms a diatomic molecule, but the sulfur is a polyatomic. Now, the sulfur forms an 8-membered ring. The tendency, as you move down the group, the size of the atom increases, the strength of element-element bond decreases. Therefore, the catenation property also decreases. Hence, sulfur has more tendency towards the catenation. Therefore, answer first is the right answer. Next, we will move on to question number 50. The increasing thermal stability of the hydrides of group 16 follows the sequence. Now, as the size of the central atom increases from oxygen to tellurium, the HM bond becomes weaker and it breaks very easily on heating. Therefore, if you observe the option second, H2TE, H2Se, H2S and H2O. The H2O is more stable and H2TE is least stable. Therefore, option second is the right answer. Next, we'll move on to question number 51. Which one of the following compound is the strongest reducing agent? Now, as you move down the group, the strength between hydrogen and metal bond strength decreases. When the bond strength decreases, it gives hydrogen very easily for the reduction process. Therefore, among the hydrides of 16th group, the H2TE is used as a strongest reducing agent. Therefore, option 4 is the right answer. Next, question number 52. Ozone tails mercury. The reaction involves. The tailing of mercury is nothing but the mercury reacts with ozone and it forms mercurous oxide, where the oxidation state of mercury is 0 here and here it is +1. And because of the formation of mercurous oxide, it stick to the wall of the thermometer and that is called as tailing of mercury. So, this tailing of mercury is nothing but the oxidation process. Therefore, here 0 to +1, it is oxidation. Hence, option second is the right answer. Next, we will move on to question number 54. Which of the following is used to purify air in crowded places? Ozone is used to purify air in crowded places. Why? Because it can be used as a germicide as well as disinfectant. Okay, so therefore option 4 is the right answer. Next, we'll move on to question number 54. The total number of single covalent bonds and lone pairs of electrons present in one S8 molecule are. Now, see the structure of a S8 molecule. In that 1, 2, 3, 4, 5, 6, 7, 8. 8 single covalent bond is present and how many lone pair? 1 here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Therefore, option 3 is the right answer. That is 8 single bond and 16 lone pair of electron. Question number 55. The halogen showing maximum coordination number of sulfur in SXN halide is. Now, sulfur, the maximum oxidation state is +6. it is possible only when it combines with fluorine. It oxidizes sulfur to +6 oxidation state. That's why the fluorine in SF6, it forms a maximum coordination number, and therefore the option first is the right answer, because the fluorine is the strongest oxidizing agent. Next we will move on to question number 56. The acid containing SOOS bond is. Now H2SO5. H2SO5 is called as peroxomonosulfuric acid, or it is otherwise called as Carros acid. In that SOO linkage is present. This is called peroxide linkage. In dithionic acid, SS linkage is present. In case of pyrosulfuric acid, SOS linkage is present. But in case of peroxodisulfuric acid, and that is called as Marshall acid, where SOOS linkage is present. Therefore option 4 is the right answer. Next we'll move on to question number 57. Oxidation state of sulfur in H2SO5. Now see the structure of H2SO5. So this is the structure of H2SO5. Now 2 hydrogen present, therefore 1 into 2 for hydrogen. Sulfur is X, we don't know the oxidation state. Now these 3 oxygen is having -2 oxidation state, that is -2 into 3, but observe this, these 2 are peroxide linkage, therefore it is -1 into 2 for oxygen, that is equal to 0. Now X minus X is equal to 0, or X is equal to +6, therefore oxidation state is +6. Hence option second is the right answer. Next we will move on to question number 58. Which of the following is a monobasic acid? Now H2SO3, if you observe the structure, here in H2SO3, the 2 replaceable hydrogen atom is present, and that's why it is a dibasic acid. In sulfuric acid, see the structure, 2 replaceable hydrogen atom is present, that's why it is a dibasic acid. In the case of H2SO5, peroxomonosulfuric acid, or it is Carros acid, and only 1 replaceable hydrogen atom. This hydrogen cannot be replaceable because it is attached to peroxy linkage. Hence this hydrogen cannot be replaceable. Only this hydrogen can be replaceable. Hence it is a monobasic acid. And in Marshall acid or peroxide disulfuric acid, that is H2S2O8, in that also 2 replaceable hydrogen atom is present, that's why it is also dibasic. Only the option third, it is a monobasic, hence option third is the right answer. Next we'll move on to question number 59. Oxygen is more electronegative than sulfur, at H2S is acidic while H2O is neutral. This is because now H2S easily undergoes dissociation and gives 2H plus ion plus S2 minus ion. Why? Because in the case of bond between hydrogen and sulfur, the bond between hydrogen and sulfur is weaker, but in case of water, the bond between hydrogen and oxygen is stronger, and that's why water will not undergo dissociation very easily, hence it is neutral in nature. Therefore option 4 is the right answer. Next we will move on to question number 60. When a colorless gas is passed through a bromine water, only decolorization takes place. The gas is. Now see, bromine react with water and forms HBr and nascent oxygen, and sulfur dioxide react with nascent oxygen, forms sulfur trioxide. Sulfur trioxide and water gives sulfuric acid. and because of this the decolorization takes place. Now here the bromine decolorizes or oxidizes sulfur dioxide as well as hydrogen sulfide. But when bromine oxidizes hydrogen sulfide and forms a sulfur which is in the colloidal form, that's why you will not get clear solution, you will get milky solution. But in the case of sulfur dioxide, it oxidizes sulfur dioxide to sulfur trioxide and sulfuric acid is formed later, and because of that it forms a clear solution, hence decolorization takes place. Therefore option first is the right answer. Next we'll move on to question number 61. The acid which has a peroxy linkage is, now sulfurous acid, see the structure of sulfurous acid, is there any peroxy linkage? No. In the case of pyrosulfuric acid, this is pyrosulfuric acid, or it can be called it as oleum, in that SOS linkage is present, there is no peroxy linkage. Third, dithionic acid, in this also SS linkage is present but there is no peroxy linkage, but in case of Carose acid there is a peroxy linkage, and therefore option 4 is the right answer. Next we will move on to question number 62. Which has maximum number of oxo group? What is this oxo group? Oxo group means M double bond O. M means central atom. Now in case of sulfuric acid, see the structure, the 2 oxo group is present. In the case of sulfurous acid, 1 oxo group is present. In case of phosphorus acid, 1 oxo group is present. In case of phosphoric acid also 1 oxo group is present. Therefore option first has a 2 oxo group, and that's why option first is the right answer. Next question number 63. Photoconductor of Xerox machine use. Please remember it is a fact question, that is selenium is used in the Xerox machine. Therefore option third is the right answer. Next we'll move on to question number 64. Which oxide of nitrogen is used as a catalyst in the lead chamber process for the manufacture of sulfuric acid? So manufacture of sulfuric acid is done by lead chamber process where the NO is used as a catalyst. Therefore option first is the right answer. Next we'll move on to question number 65. An element X burns in air to form corresponding dioxide A. On bubbling hydrogen through molten state of X, a gaseous hydride B is formed. A and B react to give back X. A and B are respectively. Now sulfur react with oxygen gives sulfur dioxide, where sulfur is X and sulfur dioxide is A. Sulfur react with molten sulfur react with hydrogen gives hydrogen sulfide, H2S is formed, that is B. Now sulfur dioxide A and hydrogen sulfide B, it react to give water and elemental sulfur is formed. Once again X is formed. Therefore A and B are sulfur dioxide and H2S. Therefore option third is the right answer. Okay students, this is a theory topic. The most of the questions are fact questions, and solve more number of questions so that the concept becomes very clear. Okay, thank you. Prepare well for the upcoming NEET and CET examinations. Thank you.